Okay, so good morning, everyone. So this is Dr. Supanna Shirguppe, Head of the Department of Electrical and Electronics Engineering from SG Balekondri Institute of Technology, Belagavi. The department is hosting a series of webinars, and today's webinar happens to be the first of this series in the month of May. So we have a very distinguished speaker with us today, Dr. Raghavendra Vishwakarma, who is working as an Assistant Executive Engineer in HESCOM, Hubballi. So he will be delivering the talk on the topic Earthing and Earth Mat. So I extend a very warm welcome to our beloved Principal Sir, Dr. Sidramappa V.E.T. In his absentia. I welcome our guest, Dr. Raghavendra Vishwakarma from HESCOM to deliver the talk on Earthing and Earth Mat. So thank you so much, sir, for having accepted our invitation and being a part of this event. Any event is not completely successful without the participants. So a very special thanks to all the participants. And I also welcome Professor Naresh Pasla, who is the moderator for this event. Then I welcome Professor Virupakshi B. Dalal, Professor Srivatsav Madhabal, and all my other colleagues to this event. So I hope all the participants will enjoy this webinar. So thank you and welcome to everyone once again.
Yes, now I request Virupakshi sir to give an introduction of the guest. Virupakshi sir.
Sir, you are not audible.
Virupakshi sir.
Yes, sir.
Yes, yes. Fine.
Yes.
Is it audible, madam?
Yes, yes, sir.
Very good morning, one and all. Respected Principal Dr. S.V.T. sir, HOD Dr. Supanna madam, our speaker Dr. Shri Raghavendra sir, my dear colleagues and student friends. I take this opportunity to introduce today's speaker, Shri Raghavendra Vishwakarma. He has completed his BE in Electrical and Electronics in the year 2001 from Karnataka University, Dharwad. Presently, he is working as Assistant Executive Engineer, HRD Section, HESCOM Hubballi. Sir has got 19 years of rich experience in the engineering field and 11 years in art of living teaching. He has worked in different cadres such as project engineer, relay testing and commissioning engineer. He was station in charge of 220 kV Bidna Station Hubballi. He was in charge of R&D cell of HESCOM Hubballi. He guided many industrial live problems and given the solutions for them. Apart from technical side, he has carried out 30 plus numbers of happiness programs like Mega Anandotsav program, Yoga Day program. He uses to give personality development lectures in various colleges. His areas of interest includes spirituality, research, and project. With this brief introduction, once again I welcome Sri Raghavendra. Thank you, all of you. Now I request Raghavendra sir to start the session. Thank you, sir.
Thank you so much, sir.
Thank you, sir.
So good morning, all. I hope everybody's. I'm getting echo actually. So, I request a mute mic other than me. Hello. Yeah. Thank you so much, sir. And good morning, all. Welcome to the wonderful world of earthing. So, my session goes like this. I briefly introduce about earthing and earth mat. It is a very unique to know that earthing and earth mat are the basis of all the electrical operations. So I'll start with this thing. So you might have seen sockets in your home and 3-pin sockets. So may I ask you one simple question? Why there is a bigger size for E, and like L and N are mains, phase and neutral, and E is for earthing. You might know that, but the size of E is bigger compared to L and N in the 3-pin socket. Why it is so? Can anybody tell me? So can anybody tell me? Somebody, some. Okay. So it means I'll carry on myself. So it is for earthing connection. It goes for the earthing connection. And one important thing you should know as an electrical engineer, I have shown a voltmeter connected between E and N. If you measure L and N, if you measure L and N voltage, what will be the voltage of normal voltage supply? Normal voltage supply of between L and N, if you measure with a voltmeter, it will be around 230 volts. And if you measure between L and E, how much it should be? And that is a wonderful thing to know. It should be 230 volts. And most of the people, we don't know that if you measure E and N, there will be some voltages. And if it is around 20, more than 10, we used to get minor shocks while we operate with computer, fridge, refrigerator, iron box, so many things, electronic gadgets, electrical gadgets, what you use. So it is because our earthing is deteriorated. So I'll take you next level. See, most of the cases, accidents, as far as research is concerned, most of the accidents happen due to using 2-pin socket, and there will not be a 3-pin. Most probably, there is no. Practically, we don't use 3-pin socket most of the time. We prefer 2-pin socket for extension and all. So most of the accidents happen due to water pumps, because we extend to a water pump connection via a 2-pin socket. And while removing or connecting 2-pin socket, most of accident happened. So if that in that case, if we have a 3-pin socket, then probability of accidents or severity of accidents may be reduced. So as you are observing, as you are watching this PPT, the electric shock, if a person get current flows from his body, it is of 1 milliampere, he just get a perception that there is a shock he's experiencing. 1 to 6 milliamperes, it's a let go current. He will get a shock, but supply make him like it throws him. I'm getting huge noise. Hello.
Yes, sir. Yes.
Yeah, I'm getting huge noise, sir. Okay.
Yes. We'll.
Huh. Okay. If that current flows from a body, it is of 9 milliamperes to 25 milliamperes, it is painful and may, if unfortunate, may lead to death also. 60 milliamperes, definitely it is going to be death. So all these cases, earthing, proper earthing will save because it will create a parallel path or a low resistance path. I know, or I hope you all know that current to flow, you should have potential difference. Whenever there is a potential difference, then only current flows. And I'll take you the human body resistance model. See, human body is also it is of basically resistance. Skin is the main source of resistance. Like it's a low resistance thing, basically skin. It covers whole body, and it what you are seeing is human body resistance model. So whenever you touch with the hand and some other part of the body touches, then you will create a closed loop. Then when there is a potential difference, definitely there is going to be flow of current. And as I said, if it is between these milliamperes, that condition going to happen. So even if you take 110 volts, severity is more. So now I come to why earthing is needed. As you got to know that due to improper earthing or not earthing, so many deaths are going to happen. Not only deaths, we will lose equipments which are operating and which are basically uh, by which equipments we are getting supplied to our home, and we are able to see now, and we are able to carry out our day-to-day activities. So earthing, basically most of the people say is grounding. So it is a different story. What is the difference between earthing and grounding? Let us assume that earthing means an electrical connection to the general mass of Earth to provide safe passage to fault current, to enable to operate protective devices and provide safety to personnel and equipments. So it covers everything. We have to take safety of our personnel and equipments, and we have to uh, pass that fault current to the Earth, and that should be measured also through our protective devices. And this is why it is necessary. What is earthing? Earthing is basically it gives all that sort of things. And neutral earthing. Neutral earthing, we have neutral of a transformer, and that is the main that is whenever we earth that neutral, then only closed loop path will be developed. Then only we can expect flow of current. So neutral earthing is the earthing of system neutral to ensure system security and protection. So earthing means we should earth all the non-current carrying parts of equipment, all the metal parts which are not at all needed or connected for electrical equipment are also to be connected to the earth in a substation. So basic objective earthing, we cannot reduce whatever ground equipment. So what we are using. See, ideally we have insulators which make huge difference. Uh, Ideal insulator is such an insulator which insulate from ground to that whatever potential we are utilizing that. But as you know, we don't have that ideal insulators, and it is very difficult to have. Such things may induce some voltages, and whenever there is a potential difference, that ground part, that metallic part, maybe structure, is tend to develop some current in that. And whenever a person, people touches that, he will going to get a shock. So zero, and how to stop that? Create a potential difference up to zero. That is zero potential difference surface. If it is made, that means there is no scope for current to flow. It doesn't mean that resistance is zero. It doesn't mean uh, voltage is zero, but it means potential difference is zero. You can see visually in a substation, when all so many equipments are there in operative condition, definitely they are going to induce some voltages, and those are all connected to a common earth mat. And I go to earth mat in the coming slides. So whenever a person stands or sits or touches, definitely there will be a potential difference he is going to create. And while creating earth mat, we have to take care of that. I'll come after some slides that what is step potential and what is touch potential. So I'll go there, and before that, I want you to understand earthing means we use a normal electrode or any metal part, maybe GI pipe or something, and we buried in earth mass, and we take one conductor, one wire, you can say, to that as earthing. So it means, my question is soil soil is a good conductor? Can you think a while whether soil is a good conductor? If it is a good conductor, and it means we should get shock whenever we walk around. And if it is not a good conductor, why we bury any metal part and we make it as a conductor? Have you thought a while? Okay. I hope you are in a confusion whether exactly soil is not a good conductor. It is not a good conductor, but how it acts as a conductor so that our fault current will flow into the earth. That is very important and very basic things to know. I'll take you to that. And one more thing, why is earthing needed, or why have you ever thought why actually we need earthing, other than all personal safety or whatever I told right now? So see, we always measure. If you take a small pen, if you can say this is 5 centimeter or 6 centimeters. So on which part, on which thing you have said 5 or 6 centimeters. So 5 or 6 centimeters, based on you have started somewhere and you have taken that as a reference zero. From that zero, it is 5 centimeter. If you start a reference about 10 centimeter, then you measure, and somewhere if you have shifted that reference, then you will be using actual measurement of that whatever things are there. Like that, it happens in our electrical system. Whenever neutral is not connected to earth as a 0 volts, connecting neutral to earth means we are making neutral as a 0 volt at potential 0 volt. Then only by that reference point, whatever we measure will be accurate. If that neutral point is fluctuating, that floats, then whatever we measures will not hold good, and our equipment will not are not prepared for more than 230 volts basically. So creating a reference point as 0 volt is of very important. So only earthing is also very important. By earthing all the things, whatever it from generation to end user to our home, we have created, because everywhere we can have a earth. So we made that as a reference. Wherever you go, earth will be treated as a 0 volt potential. So we have connected all our equipments wherever it is to earth, so that that will be taken as a one reference at 0 volt potential. And like that, uh, things are researchers are going that future days we may see that one conductor will be eliminated and earth can be treated as a conductor itself. Researches are going on. So coming to the soil, is it a good conductor? No, it is not a good conductor. But then how we are using that? So somewhere, a low resistance value in itself is not a guarantee for safety of. Okay, coming to this. So this is a plot we can have between resistance and area of earth. So whenever you plot that relation between resistance and earth area of earth, as per our formula, it is very evident that whenever we consider huge infinite large area of cross section, because earth we cannot measure and it penetrates in a very in terms of kilometers, so it behaves as good conductor. So only we bury our conductor, so that that creates a cross sectional area of literally an infinite number. So coming to that, then which is the best conductor to bury, to use as a for earthing? So earthing basically, you might have seen in earlier days, around 100 years back, uh, we all earthing are of copper. So basically corrosion is very less, and the minimum thickness of copper itself is suffice to carry out all earthing activities. And as copper is prone to theft and all, and economic point of view, we have taken GI, but GI's corrosion is um, comparatively high, but again it has a lifespan very less. So get we got for cast iron. We have taken a thickness, more thickness, but uh, taking care of corrosion effect, and it acts as a very good conductor when it cast iron, which is not painted or which is not galvanized, or cast iron acts very wonderfully in the soil. Definitely there is a corrosion effect and it's more, but as we consider thickness, a higher thickness, and it gives around 100 years of its life. So now coming back, fast check. Fast check means, see, typically we can give, then what should be the resistance of earth mat, if you can see. So EHV, large EHV session should have less than 0.5 ohms. It means you have, if you have taken a ohm meter or a resistance meter, whatever you call it as, but whenever that earth itself, you can see it as a metal part or a surface, conducting surface. When you can measure that with a other earth reference, that resistance should be less than 0.5 ohms. We'll see how they measure. And small EHV, it's 1 ohms, less than 1 ohms or 1 ohms. HT consumer 33 kV and all, less than 2 ohms. Medium voltage consumers are 5 ohms. Domestic consumers like we household people should have a resistance, earth resistance around 100 ohms. So fast check is during earth fault, earth potential can rise to several kilovolts for short duration of less than 1000 milliseconds. Earth potential rise when because that a lot of current is induced and uh, diverted to earth, so earth potential will rise. Earth design cannot standardize based on stationary capacity or voltage class. See, earthing design is totally is not you cannot standardize. You have to check the soil level and type of soil, stratas of soil. So many things are there. That is very huge research studies to be carried out while designing earth mat. So now you will wonder whether if for domestic, if it is 100 ohms, let us assume we may reduce it to less around 10 ohms or 20 ohms. Whether I am very safe, then no. A low resistance value in itself is not a guarantee for safety of personnel. That don't ensure. That is parallel path provided, but you should maintain whenever you are using any electrical personnel, you should maintain potential between 0. Use of copper may help in reducing corrosion, but it will not ensure low earth resistance. Most of the people will say saying that use copper only. Uh, let us assume we are not worrying about economics and all. I'm very rich, so can I use copper itself? So, need not be, because copper is not a thing for low resistance or creating low resistance. It is a thing to penetrate in the earth, buried in the earth, and size of that, and creating paths, interconnectivity, so many things are involved. So if you got to know how soil and all, so as I said, coming to some step potential, and see, this is a step potential. You might be seeing this. So he has stepped out. I will assume a 1 meter distance between two steps. Whenever he steps on a substation or in a substation, whenever he moves, say 1 meter apart. So potential at this step, left step and right step, is not same. So there will be potential difference set up by him, as we know he is a resistant model. So definitely potential difference divided by resistance is equal to some current, and if it is more than 60 milliamperes, then that can happen. So we have to ensure, because we cannot lay a metal surface, we can create a earth mat virtually as a, it will be seen as a metal surface. So we have to create potential difference between each 1 meter distance apart should be potential difference to be 0. And another part is touch potential. You can see he is standing here, there is no step apart, but he is touching another equipment. So definitely these steps are at one potential, and he touches any other equipment, it is at different potential. So definitely there will be a potential difference, and that means potential difference divided by resistance is equal to some current. So it is also a dangerous thing. So this is called as touch potential. So we have to consider that also. Touch potential should also be made 0. Touch potential is not 0, but difference between two potential things. Basically, we call it as touch potential. You have to make it 0. So that is what is called now step potential, the maximum value of the potential difference possible of being shunted by a human body between two accessible points on the ground, separated by the distance of one place, which may be assumed to be 1 meter. And that's potential, the maximum value of potential difference between a point on the ground and a point on an object likely to carry fault current, such that the points can be touched by a person. So here is clearly shown. This is at what one potential, another potential. Whenever fault happened, maybe lightning happened, we made a proper earth, but that earth current, fault current will flow to the earth. And whenever person walks, that soil, that earth is, is created with different potential gradients at various points. So this is going to make a potential difference. So while designing earth map, we have to eliminate this and to make potential difference zero. And the same case with this earth potential. So that can be viewed as a realistic model. Again, like this. So we call as electrodes. Electric and nothing but metal rods and cast iron or metal. Once we're driven into the earth and non-current carrying metal parts of electrical apparatus and connected to these rods for electrode. So now earth resistance means what? Earth resistance, as we have already saw that what should be earth resistance value, typically for a home, domestic, EHV, VHV, and that. Earth resistance is nothing but earth electrode is the resistance offered by the hemispherical mass. Please note the point, it is hemispherical mass of Earth. It's not a single dimensional distance, it is hemispherical mass of Earth surrounding the electrode wherever you are measuring, whichever things you are measuring. For the flow of current leaking from the electrode into the Earth, where the radius of hemisphere is the distance from the electrode to the remote Earth. So usually this is we always call this as Megger. It is a company called as Megger created first earth resistance measuring kit. So we are practice to call it as a Megger. It is not Megger, it is earth resistance measuring kit. That's it. So it comprises of four pegs, you can say, and have to be driven like this. Then measuring that, these are even into our potential pegs and signals into our current electrode. Measuring and of same standard size. So it will give you a resistance value. It is typically we inject around 100 milliamperes current in our current electrode, and whatever between these potential P2 voltage is developed, that is measured, and as we know, a fixed current is injected by a system. So V by I equals to R. Okay, calculates and says. So when we see copper has a very less micron centimeter, it is used most of the time, but because it resistance is very low, as I said, is not the criteria to create zero earth resistance. As you see soil, it is not at all a good conductor. So going to the next level, as I said about step potential and touch potential, now our main objective is to create a earth mat or earthing is to create a zero potential difference surface in and around and under the area where the electrical equipment is installed. I'm talking about the substation typically because once we know what substation, we can always apply it to any smaller area. And as you know, earthing, why it's important and how it is taken as a zero reference. All this is because generating station, distribution, transmission, distribution, all our equipments, all our neutrals all are connected to the earth, created as a zero potential reference. So now these are the grid guidelines while we carry out Earth map. So and how joy will be given by the R&D department. So they will be knowing, they will be calculating soil sensitivity. They visit the place and they take samples, varieties of samples across the area. Then we will decide soil sensitivity. Then based on that and how much area we are planning for a creating substation, based on all that, and they will do earthmat drawing. So based on earthmat drawing, we will carry out earthmat drawing. So earthmat drawing is typically like this. Typical diagram of earthmat is like this. So we have rows and columns running of GI flats, and there will be vertical electrodes. These are electrodes, are rods. They will be penetrating toward the area and are of around 2 meters. And other than that, we have GI tabs. Those are specific for equipment, and these are called as risers. These are called as risers. So risers are used to connect the equipment, and these electrodes are used to create a uniform things to allow for current to move, penetrate into the earth or sink into the earth. So I hope you are seeing this. When you go, it's a very small area, so they have welded like this. And it's not the case to be carried out when you are going for earth mat. It should be like one above the other. It should be like being as a mat. So typically, it is like this. You have to run a flat. Flats, GI flats are available of maybe 6 meters and are welded. And whenever you weld, that welding portion should be more than like double of that area. So overlap, I have given all these things, and later on you can know that. You can know down it later. So that is I'll briefly cover what is very important. So this is GI path used for substation and wherever a transformer of higher capacity used. So this is like 2.75 meter line, and up to collar it is buried in the ground. See, it is welded. The collar is welded like this toward the pipe, and this is cast iron. It should not be painted. It is typically inside up to this, and bury that. Later on, we take this collar to be welded with a GI flat. It should not be threaded or bolted. Okay. So my voice is not clear. I'm audible now. If I'm audible. So, these are the wrong practices to carry out. Bending and crossing. These are wrong practices. See, this is wrong practice. This is wrong practice. You know the common sense logic behind this always wrong. Because whenever fault happens, we should make it like a highway so that it immediately penetrates and sinks into the earth. These are the things we carry out in the field. This is a wrong one. It should not be gap like this. It is not welded. So these are rejected ones. So as I have told about the risers, these are called as risers. These will be from earth mat. All the earth connections are to be equipment cast iron pipe input. These earth mats shall be made using galvanized steel flats. These are galvanized steel flats. And these are not to be used while creating earth mat. This is only for razors. And typically all should be welded. There is no scope other than welding. It's in cable, in panels, in new panels, how we use. There will be substrate wire is provided for earthing. This is going to connect it for earth to the earth mat, and this wire is for making this metal part at same potential as the earth. I hope you are seeing all these things. These are live things to be connected, but again we should not forget to connect earth wire, the metal part, so that this panel should also be earth. It's a universal thing that there should not be any electrical electrical equipments connected to metal parts, connected to electrical equipment should not be. It is universal that you have to connect all metal parts composite to earth. And these are cables, UG cables. See, UG cables have a good, it is armored and it carries separate flat, and it is connected to these things like this. So RTP made for connecting earth mat. These are single core cables, and there will be 3-core cables also. This is how we have to connect. Now going into detail, it's not connected to the people. I think whenever we visit any station, substation, we will understand. Anyway, continue afterwards. So I'll tell you one thing. Okay. Coming to power cables, there are 3-core cable and single-core cable. So most of the practice, what we normally do is we connect both the ends, because cables come with earthing options both the ends, and we tend to connect both the ends of 3-core cable and single-core cable together. See that whenever we connect both the whenever we make both the ends of a single-core cable, it will create a path for current to flow. That will make that is a damage that will going to create damage to the cable. So while for single core cable, it is should be connected at one point, and for 3-core cable, both the ends should be connected.
Hello, sir.
Sir.
Sorry to interrupt, sir.
Sir.
Sir, please little bit increase your volume, sir.
Oh, how should I increase? I'm not getting, sir.
Okay, sir, no issue. Please off your webcam, sir. So maybe because of that, some disturbance. Webcam, sir.
Webcam.
Yes, it has been on, sir.
Which webcam is on, sir?
Yours laptop, I think, sir.
One second, sir. We have not tested that. Sir, I mean, I'm not getting which microphone is connected.
Mic.
So,
Okay, sir. Let's continue.
because we have not tested earlier any connections with the okay.
Okay, sir. Let's.
And one second, sir. Now, it's audible, sir.
Is audible, sir.
Okay, we are not. I forgot to change microphone.
But your webcam is still on, sir. No issue, sir. You can explain.
Okay. So I've covered a lot of things. I should have known this earlier. Anyway, I thank all the students who there with me. So, okay. So it's now
Okay, sir.
I'm going.
No problem, sir. You can go.
One typical is that all our level students start from a substation. Most of the time we see electricity supply is available in our substation, but that is not the case with immediately next to our substation. So most or people will blame for that. Some people have supply, but we don't got that. So it is this if, if we run the supply uh, from substation to the other outside the fence, definitely there is going to be potential. So we don't connect our supply from substation to the outside. It's only to the fuses, not our substation transformer will outside supply. When fuses are erected outside and inside, there are two possible questions or options, situations. Our current fuses are connected to the substation and outside the substation. So from whatever whatever equipments are inside the station are to be connected to the customer. And once it crosses a certain fence, it should not be connected to customer. So these are the possible, so this is very new thing for this project. Huh. And one another question we get to know usually get substation fencing. So substation fencing is very different. It should not be connected to earth. Or, anybody can touch that fence. So it should not be earth. Again, it should have its own earthing system. So this we have to know very clearly. And usually we say don't touch fence because if we stand in earthmat area and we touch fence, there is going to be definitely potential. Uh, this is you must have seen jelly spread all over in the substation. Do you know why it is done? To create actually websites are busy over the data and create a uniform area. Okay. I will. I think I have covered most of the things. Unfortunately, you will not heard properly. Maybe sorry for that. These every time we come with standards and are insisted upon so many standards are there, but these are to be considered by us. So, we use a typical earthing layer diagram. So you might not understand at the first instance, but you're going to understand when the station and you know where you stand and how you need your wherever you are moved. You need that gas flags are run made as a map. So it gives a fair idea how to do that, and it is done based on where our equipment stands and how many AI clusters are buried and uh, are connected other than Athena. So I have covered as per my time all that I have rushed through because it's a very dry and very cool subject. So most of the things you may not understand as of now, but once you visit station for station and you feel the magnanimity of whenever there is a failure of our connections, how equipments will get flash over and burn and how accidents happen, then you will understand the problem. So I have covered basically all the possibilities answers to question and asthma. If you have any questions, I will answer.
Yes, sir. Thank you so much, sir. Now,
Any questions?
yes, dear participants, any questions? Yes, please.
No.
Yes, sir. It's a nice presentation. I request Srivas.
I thank you all for participating and I thank my honorable MD, Abdul and actually and my executive engineers for creating opportunity. And these PPT can I'll be sharing with your professor. It's going to be a basic guidelines or the handbook type. Most of the things are covered here. And whenever we come across any questions, we can refer it back. Thank you so much.
Sir. Yes, I request Srivas sir to give a concluding remark and vote of thanks.
Very good afternoon, sir. Good afternoon, everyone. I'm Mr. Srivatsa Madba, Assistant Professor, Department of Electrical and Electronics Engineering. Deem it a great honor to propose the vote of thanks. First of all, I would like to propose my hearty thanks to our distinguished speaker, Engineer Raghavendra V. Sir, Assistant Executive Engineer, HESCOM, Hubballi, for accepting our invitation and making their webinar interesting, meaningful with your excellent presentation and discussion. Thanks for your valuable time, sir. I would like to express our profound gratitude to our respected principal, sir, Dr. Sidramappa V. Itti, for their kind encouragement and motivation. Thank you, sir. I would also like to thank our beloved HOD ma'am, Dr. Supana S. Shirguppe ma'am, for their moral support and guidance. Thank you, ma'am. A special thanks to Professor Fasla Naresh, Department of Electrical and Electronics Engineering, SG Balekundri College of SGBIT, for organizing this event very systematically and making it a grand success. I'm happy to express my heartfelt thanks to all the faculty members of Triple E department from SGBIT as well as the other college respected like Jain College faculties for their kind cooperation and active participation. Last but not the least, without whom this webinar would have been incomplete, a sincere thanks to all the student. A sincere thanks to all the student friends and other participants from various colleges for their active participation and making this seminar a grand success. Thank you all, and I thank the organizing committee for providing a wonderful opportunity to present my vote of thanks. Thank you, sir.
Yes. Thank you once again, sir. Now we will
Thank you, sir.
Raghavendra,
Yes, sir.
Raghavendra sir. Thank you.
Yes, sir. Yes.
Sir, you can.
Thank you, sir.
I would like
Sir, you can.
to express my heartfelt thanks on behalf of the department, sir. Thank you
ma'am.
so
Thank
much
you,
for
ma'am.
sparing your valuable time and being a part of our event. So I expect we will keep this association in the next future also. Thank you so much, sir.
Yes, definitely. As from actually wants student to know the field conditions to have uh, motivation to study their engineering come with solutions for the real world. So, we will look into that.
Thank you.
Thank you, sir.
Yes.